In this lecture, we're going to see how we can pass by const pointer to const. This is a setup that is both going to prevent people from modifying the data that you point to in your parameter, but we can't also make the pointer point somewhere else. This is a simple example to show this scenario. And here we have our signature, which is saying const int pointer const. You might recognize that this is a syntax for a const pointer to const, a pointer through which you can't modify what you are pointing to, but it's also a pointer for which you can't change the location where it is pointing to. If you look at our definition here, this is our definition. It is the same as our prototype on top. But if we go inside and try to do something like this, we're going to get a compiler error because we can't go through the pointer to change what is pointed to. This is exactly what we saw in the last lecture, but we also can't do something like this. We can try and make the pointer point somewhere else. This is a global variable that is called dog count. You see it on top here. But now in our function body, we are trying to make it point to another location. And if we do this, we're going to get a compiler error because this is a const pointer and we can't make it point somewhere else. This is the behavior we have here. And sometimes in your daily job as a C++ developer, you're going to need something like this, and this is how you can set it up. For now, we're going to head over to Visual Studio Code and see this in action. Okay, here we are in our working folder. The current project is passed by const pointer to const 17.9 here. So we're going to grab our template files like we always do, and we're going to put them in place 17.9. That's the current project. And we're going to open this in Visual Studio Code. Let's do that. 17.9. We are going to open the folder. Let's open our main CPP file. And we are going to put in the code we had in the last lecture. That's going to be our starting point. We can close this left pane so that we have some breathing space. So what we want to do is to change this function to pass our parameter by const pointer to const. Right now, it is a pointer to const, and we need to make it a const pointer. That's easy to do because you know how to work with pointers. We're going to just add another const keyword after the star here. Let's go down to the definition and also do the same. And the moment we do that, if we try to uncomment this line that modifies what is pointed to, we're going to get a squiggly line because this is bad. We can't do that. We saw this in the last lecture. But if we go on top and set up a global variable, let's say int dog count. You can name this whatever you want. This is just a simple example. We're going to put in 2, and we're going to put our closing semicolon. And if we go down in our function here and try to make our pointer here, which is age, point somewhere else, we're going to get a compiler error. Let's try and do that. We're going to take age and assign the address of dog count to it. If we do that, we're going to get a compiler error because we are trying to make this pointer point somewhere else. But this pointer is a const pointer, so we can't really do that. We can't make it point to another location. We're going to get a compiler error, and this might be something you want in your application to stop people from doing this. And if they do this, they're going to get a compiler error, and they are going to probably fix this and find another way to do whatever it is they want to do. So if we take this out, we comment this out, we're going to build fine. We can build with GCC. We're going to build fine. But I don't think I showed you the compiler error. So let's take this back and build so that you can see the compiler error that we get if we try to modify where a const pointer points. We are going to get an error that is saying you are trying to modify something that is read-only. That's what we see here. And this is bad. You shouldn't do this if you are going through a const pointer. We are going to stop here in this lecture. In the next one, we're going to see how we can pass our parameters by reference. Go ahead and finish up here and meet me there.